chapter 1. We're going to start out with doing a warm-up. So if you could do the 1, 2, 3 warm-ups, hit pause, and whenever you hit play again, I will show you the answers. Okay, number 1, now that you're done, remember you need to get a common denominator. What can 3 and 18 become? Both, they can become 18. So our common denominator is going to be 18. So we're going to have 5 over 18 because it's times 1 times 1. 3 times 6, 2 times 6. 2 times 6 is 12. Then you add your numerators. 5 plus 12 is 17 over 18. Put 24 over 1 when you're multiplying. Cross simplify. 4 divided by 4 is 1. 24 divided by 4 is 6. 6 times 1 is 6. 1 times 1 is 1. Make sure you simplify it, and your answer is just plain old 6. Now remember, when you're doing division, you have to do keep it, switch it, flip it. So you keep 2/3, switch to multiplication, and flip it to 12 over 6. Again, we have lots and lots and lots of cross simplification. 3 divided by 3 is 1. 12 divided by 3 is 4. 2 divided by 2 is 1, and 6 divided by 2 is 3. So now multiply across the top. 1 times 4 is 4. 1 times 3 is 3. So you have 4/3 or 1 and 1/3. Either answer is fine. Okay, now we're going to go over a couple of, here's your homework answers. You can hit pause and take a look at those, mark which ones are wrong, and come and see me if you have any questions. We're going to go over a couple of definitions. A variable is a letter or symbol used to represent a value that can change. So a couple of examples would be X, Y, Z, K. I make my T's with a little bottom part. A constant is a value that does not change. Basically, it is a number. It could be 3, it could be 10. It's a number. 3 is 3. A numerical expression may contain constants and operations. Operations are going to be plus, they're going to be minus, they're going to be times, they're going to be divide. So an example of a numerical expression might be 3 plus 7. Notice it's all constants. Where we start using variables is in an algebraic expression because it contains variables, constants, and operations. So this is where you might get x plus 7. Make sure if you're using multiplication, you would want to write 8x. You always want to have your number first, and it's called your coefficient. And to evaluate is to find the value of an expression. For instance, to evaluate 3 plus 7, it is 10. An expression is not an equation. There are no equal signs, because that would be an equation. Now I want you to take a second and let's think of as many words for each one of these symbols that we can think of. So for instance, for the first one, we might say addition, we might say sum, we might say plus, more than, increased by. We might also say something like greater than. And write down any other ones that you can think of. For this one here, yes, it is subtraction, so we could write subtract. We could write difference. Less than is a big one, and it's where I see most people make mistakes, and so we are going to use that here in just a second. So there's less than, decreased by, and there are a couple other ones. We'll see if we can think of some more later. For this one here, multiplication, multiply, the product, multiplication, and some other ones. This one here, we have divide, split into equal groups of, the quotient, that's the big word that you want to use for that one. Now let's go ahead and write 2 examples of each algebraic expression. For this one, with addition and subtraction, the order does not matter. Please make yourself a note that the order matters for subtraction and in division. It does not matter as much in the other ones. So let's go ahead and make up some words. We're going to translate into English. So you might say here, let me make this font a little bit bigger. Maybe go 20. We could say the sum of 12 and 7. We could say 7 more than 12. So there's 2 examples. This one here, number 2, the big one is make sure it is x less than 8. Give yourself some stars, some exclamation points, something that's going to help you remember that it is x that is less than 8 because x is getting smaller. It's making 8 smaller. So it has to be x less than 8. Another thing you could say 8 decreased by x, or 8 minus x. We didn't add minus up here, but we can go ahead and do that. Mainly because it's not the best way to say it. It's more elementary. Now when we move on to number 3, we could have the product of x and y. We could just simply say x times y. And again, we didn't put that one up here, but we can add it up there. X times, because it is a word for multiplication. You could say x multiplied by y. Those are all good. Now when we go on to number 4, we could have the quotient of 8 and n. And notice it's really important that 8 came first. Your 8 had to come first because your 8 came first here. That was really, really, really important to say. The next thing you could say is 8 divided by m. This one down here is a little bit more tricky, but you can definitely do it. Let's start it out with the sum. This is the sum of the product, so you always put what you have first, the product of 3 and n, and that and right there, that represents the addition, and the quotient of n and 2. Again, this and right here, and this isn't on your notes, but add it. This and, because you said the sum of, this right here went on the left, and represented your plus, and this was on the right. Now let's go ahead and look at doing it backwards. The sum of 15 and 6. Sum we know is plus, so it's 15 plus 6. Number 6, 8 less than n is n minus 8 because 8 is being smaller. The quotient of 12 and 15. We are in 8th grade, so you want to write it as a fraction. Do not write it like 12 divided by 15. This right here is 7th grade. We want to write quotients like this in 8th grade. 12 more than 6, well, you have 6 plus 12. And again, if you had 12 plus 6, that's fine because it is addition and the order doesn't matter. The product of x and 7. Write it as 7x. Do not write it as x times 7 because it's just, that doesn't sound as good. Think, if x represents xylophones, you would say I have 7 xylophones. You wouldn't say I have xylophones 7, so make sure you do write it that way. Now this one here, this is very similar to our last one. We're just going to talk about it. Go ahead, write this down, number 10. The sum of, oh, we know we're going to have a plus sign. We know there's going to be something to the left and something to the right. The sum of the quotient of 7 and n. Okay, that's going to be my left. 7 over n, and represents my plus. 15 is on my right. And there we go. Now lastly, let's apply this to the real world. Joe is x inches taller than Mike, who is 63 inches tall. Write an expression for Joe's height. If he's taller, we know that means addition. So it's 63 plus x. Number 11 says Tom earns $40 a week. Write an expression for how much he will earn in W weeks. So if he works for 2 weeks, he earns $80. How did I get that? 2 weeks, he would have had 40 times 2 is 80. So I'm just going to say if I don't know how many weeks W, it would be 40 W, 40 times W. This one's a little bit more challenging. You really have to think. Elizabeth earns $5 for every car she washes. Write an expression for the number of cars she must wash to earn D dollars. So I want to know the number of cars she has to wash. Well, let's say instead of D dollars, she wants to earn $50. Well, to find out how many cars she would have to do, well, 50 divided by $5 per one car would be 10 cars. Well, if I just replace the 50 with a D, we get D divided by 5, and that's going to give me the number of cars that she needs. When it says to evaluate each expression, when x equals 4, y equals 2, and z equals 5, you just substitute the number in. So for number 13, when it says x plus z, x is 4, z is 5, so 4 plus 5 is 9. And I got those there, x equals 4, z equals 5. Y times z, y is 2, x, 2 times 4 is 8. We're evaluating. In 15, x divided by y is 4 over 2, which simplifies to plain old 2. Those are 1-1. You can go ahead and please check over and start your homework, which was page 9, numbers 8 through 28, even, numbers 33 through 35, all, 38, 42, and 43.